Assalamualaikum warahmatullahi wabarakatuh. Welcome to Manufacturing System Laboratory in tutorial manufacturing process. So, in this session, we will learn about the first myth of manufacturing process tutorial called design process. So, this is the outline about our first meeting now. Start from the definition of design process itself until technical or engineering drawing. So, what is the definition of design process? Design process is one of the manufacturing process activities in designing a product. An engineer must make well and proper preparations in design activities to the process of making the product. In the design of the manufacturing process, there are several things that need to be considered so that a product can be produced properly. The things that must be considered are the bill of material, assembly chart, product size and tolerance, operation process chart, production flow, process plan sheets, and technical drawings. In this case study, we will make a multifunctional bookshelf. So we will learn about how to make a BOM, OPC, assembly chart, and etc. for multifunctional bookshelf. The next one is bill of material. Based on its constituent components, BOM is divided into single-level bill of material and multi-level bill of material. In this tutorial, the BOM uses a multi-level bill of material and multi-level tree bill of material with its constituent structure in the form of a multi-level tree. Multilevel tree bill of material or product structure tree is defined as a chart of information about the relationship between the final product and all of the components. Multilevel tree is intended for products that have a sub-assembly process. The next one is multilevel bill of material. The definition of multilevel bill of material is a structural description of the materials, parts, subassemblies, and quantities used or required to assemble, combine, and produce a final product. As you can see on the screen, there are a table that show us about the level, part number, part name, material, quantity, and make or buy. In level, it shows us about the level of part of the product. There are 0 level, first level, and the second level. For the part number, there are 3 digits of number. The first digit is defined as a number of process. The second digit show us about the level, and the third digit show us about the definition of its material of the part that we will produce. So the part name, the material is iron, MDF, wood, and PLA. The quantity of the part and make or buy. If buy, so the company will buy to the vendor, not to make itself in the production on the shop floor. So the next one is multi-level tree bill of material. As you can see on your screen, there is like a diagram that shows us a 0 level, first level, and the second level. In each part, there are a part number that I already mentioned before. 3 digits here show us, the first digit show us about the process order, the second one show us about the level, and the third digit is show us about the material code. So we have to define the material code first. 1 is define iron material, 2 is MDF wood, 3 is PLA, 4 is iron and MDF, 5 is MDF and PLA, and 6 iron, MDF wood, and PLA. So if for the example in main body, it contains the iron base such as material is iron, and the MDF pack is material is MDF wood. So the main body is contained by 2 materials, so we have to define a new material such as iron and MDF. So this is a new material for the contain the main body. And same things for the features and the multifunctional bookshelf. That, and the next one is assembly chart. So assembly chart is a type of diagram that describes the relationship between components that will be assembled in the final product. So as you can see on your screen, there are start from the left side. You can take this from the multi-level 3 bill of material. So we can see this is an iron base and iron side that can be assembled like this, iron base and iron side. This is the first process and this is the second process, so we have to assemble them first. Iron base, iron side as SSA1. And after that, we are going to the third process is MDF bag that will assemble for the sub assembly one. So they will make a sub assembly too, like this. We have to assemble the iron base and iron side. After that, we will assemble them too with the MDF bag. For the MDF partition, 3D print pencil hole, 3D print partition, 3D print storage, we will do the assembly process like you can see, as you can see in the assembly chart here. So if we already assemble them based on the multi-level 3 bill of material, we have one final product called A1. After that, we will make some or have some inspection things in here. We can get the code as I1. So this is some legenda of our assembly chart. There is, if the circle, it shows us about the component of assembly operation, and if the square of this legenda, we can call them as an inspection process, like that. Okay, assembly chart is also defined as a graphic depiction of the flow sequence of components and sub-assemblies that will be assembled into the finished product. Okay, the next one is operation process chart. Operation process chart is a diagram that describes the process steps that will be experienced by raw materials regarding the sequence of operations and inspection from the beginning to the finished product as a whole or as a component. In this table, as you can see in your screen, there are circle and there are rectangle and triangle. So for the circle, we call the symbol as operation, that activities occur when the workpiece undergoes change in properties. For the rectangle is inspection, who occurs when the workpiece undergoes an inspection process, both in terms quantity and quality. And the last one is triangle, show us about the storage, and storage occurs when the workpiece is stored for a long period of time, or we can say is same as inventory, like that. Okay, so this is the example of operation process chart. For making this operation process chart, we can start about the first part that can be produced. We call this iron base, iron side, MDF bag, MDF partition, 3D print pencil hole, 3D print partition, and 3D print storage, like that. So in here we can make a circle symbol because it shows us about the process. Okay, so in this section we have a name of the process, a measurement, iron measurement, and the ruler is the machine or the tools that we can use it for the process in this section or in this step, like that. Okay, so this is, we can give some number. Okay, so 1, 2, 3, 4, and 5, and before we have to write about the part number. And in this left there are 1 minute. It shows us about the time that we need to produce in this process section, like that. So, and this for the 0 millimeter, 0.8, 0.8 is defined about the tolerance about the measurement of this part, like that. And in this rectangle, we have a rectangle in here. It shows us about the inspection, like I have mentioned before in assembly chart. Okay, do the same things or the same step to the another part. And in here, if you want to assemble the part for each part, so we can take the arrow here and then we can take the circle section or circle symbols in here for the assembly process, like that. In here we can show that assembly with welding, and the welding machine is the machine or the tools that we need to process this session, and the time is 10 minutes, and we can go through it for all the part until the final product and arrive on the triangle section in here that show us about the store, in warehouse, or finished product, or we can call it as an inventory. It's just the same. Okay, so this is the closer look of the operation process chart. Can take a look first. Okay, after that we will discuss about size and tolerance. Tolerance is a deviation that is allowed or permitted. Each basic measure is given two allowable deviations, namely the upper deviation and the lower deviation. Due to the presence of the deviations, a workpiece is made and processed using tolerance so that the workpiece can be installed and assembled. For the general tolerance is a measure given to a process that doesn't require very detailed precision. The general tolerance value always has the same upper and lower deviation limits. So this is a table for the tolerance, size and tolerance. There is a normal size and permissible deviation. We have fine, medium, and coarse. For fine deviation is having the exact size of the two parts when assembled. Medium is less accurate in size of two parts when assembled, and the last one is coarse deviation, that is not having the correct size of two parts when assembled. For example, we can, as you can see in the second table here, for the part MDF, we will measure about the lead width and height. For the lead, the actual size of the lead of MDF partition is 190. So we can see in this range between 122 until 315. So 190 here is included in this range. So we will use the fine permissible deviation. So this is, we will take the 1.2 in the tolerance. So the final size, if we use the lower deviation, we have 189.8, and the final size in centimeter is 18.98, like that. Okay, next one is process control plane. So this is representation in the form of a sheet that states the sequence of operations along with their parameters in the manufacture of parts of a product. So in this process control plan, we have a process number, operation description, workstation, setup number, setup tools, until total time. Number, in here you can fill it with the number of process. Number part you can fill from the multi-level 3, and the part name, and the created by who and when it's being created. Page 2 you can fill it with the blank table. For image file you can input the image of the part, for example is iron base. The material and the size you can define it here for the lead, width, and height. And the process number and the operation description, workstation, the setup like number setup, tools that being used, and this is tools and measuring instrument, markers, coolant, and etc. Setup time, runtime, and total time. For the total time, if the process is contain the setup time, so you have to make a summary of them. So we have to make a summary of the setup time plus the runtime. So there will make the result of the total time of that. For the difference of these tools in the setup and these tools, in the tools in setup, is the tools that from the internal of the machine, and the tools in here is contain the external from external machine, like this coolant, files, and stingy, measuring instrument, ruler, and etc. That, and with tools we can have the some things in phrase machine, like for the tools in here in internal of the machine, like phrase, milling, and etc. The next one is technical drawing. Technical drawing is a tool as an expression of ideas and thoughts about the system, how it works, construction, specification, diagram, chart, circuit, and instruction that aim to provide information expressed in the form of the image. So this is the example of the technical drawing, as you can see on your screen. Okay, it shows as the dimension of the product, the width, the height, and etc. So this is a technical drawing. Technical drawing has a drawing header that can provide some information about the technical drawing. We can see in here is a BOM table and the main part. The BOM table is used for a product that has more than 2 parts. Then the main part is used in each product, whether it is an assembly product or a product that only consists of one part. Okay, we can take the scale, we can give this part name and who is make this product, and etc. So this is a technical drawing, like projection of the technical drawing. There are European projection and American projection. In this tutorial, we will use the American projection, which is contain the isometric view, top view, front view, and right view. The technical drawing is contained by 2 types. The first type is the American projection, and the second one is European projection. In this tutorial, we will use the American projection view. We have isometric view, top view, front, and right. So the difference between American and European is a symbol in here. So as we can see on the previous table, so we can say that we use the American projection because the symbol is same like this. Okay, that's all from this meeting. Don't forget to read the module and finish your tasks before the next tutorial. See you on class, Simaners. Wassalamualaikum warahmatullahi wabarakatuh.